Perfect. And you should all have gotten notifications that everything from now on will be recorded. And just for reference, the recording here will, just like the first one, be available as soon as I get it on the website, along with the presentation. So the website, the webinars.tanzu.dk, is where you want to see everything. So, but thanks for joining. This is the hard second. There was a lot of interest in the first one. Thank you for all who attended, and we'll try to follow up and actually try to build on some of the things that we started in the first one in this second one. So for those of you who don't know me, my name is Rob Jensen. I'm lead system engineer in the modern application business unit in VMware. So everything that has a label that's called Tanzu is something that I have focused on. So the agenda for today has changed a little bit, and sorry for that if some of you are on this call just to see the ones that I actually removed. But the first one is how to get started with DevOps, GitOps, or DevSecOps. The next one is what skills and tool sets are actually needed. And again, this will be quite opinionated from my side. That's how it is, and you'll see why. And then how to actually run your applications in-house. So I'll focus on the on-prem data centers in this case today. We had something around databases, but not the next time, but the next time again, which will be the 12th of September. My colleague Matthias Silverberg, would actually do this and have a full session around the data services. So that will be around databases, RabbitMQ, etc. So I'm looking forward to that. And then I moved the one around how to monitor your applications. Part of the reason for that is that it's a big thing. It's something that takes quite a lot of time, and I don't think we have time today to really give it justice. So I'll put that at a later note. So I hope that's okay and you're not too disappointed. If you are, then drop an email and I'll reply back with a sorry. So the purpose of this webinar is just like the first one and the ones after this, to give you an introduction to cloud native services. And the idea is to start with basics and then take it to the next level, to say. This one will be a bit more advanced. Some of the topics are a bit more advanced, but I'll really try to keep them as simple as possible. So I hope you, for those of you who don't know GitOps and CI/CD pipelines and etc., I hope you actually get an idea of what this actually means. Questions, please use the Q&A function. I have my colleague Vesco sitting and monitoring that one, and he will answer that. And for the questions I can't see, we'll take them in the end. So I hope that that's okay, because I can't both present and see what. Yeah, Jørn, you're saying something. I don't know if you can unmute yourself or you. Nope. Yeah, I think you need to write in the chat for this to make sense. I don't know if you can do failure. Okay, no problem. So it's I'll just continue then. So again, if you have questions, put it in the Q&A, and I'll make sure that we answer it here or afterwards. So the first one here, how to get started with DevOps and what is actually DevOps. So I think this drawing is actually pretty easy, a pretty nice way to show it. It is all about collaboration. It's not around having silos where you just drop your packages onto the next team. And if we go down a little bit deeper, DevOps is not a product. It's a methodology on how you work together as Dev and Ops. So it's the focus here is to shorten the system development life cycle. But again, it's all about making better software, releasing faster, just like we talked about in the first one. And it's a collaboration between Dev and Ops. So really important. It is not a tool, and it's not a piece of software you can buy. If you have anybody knocking on your door saying, hey, we will sell you some DevOps, throw them out. That is not how you do it. And because of that, DevOps is not our focus today, even though I use that as kind of a spoiler. Our focus today will be around GitOps. So what is GitOps? Well, GitOps is, it's kind of the same, but the idea here is that you take everything you have, all configurations, everything, and you put them in some kind of source control system. And source control systems is, that is for most cases, Git. So you take everything and put it in Git and then work from there. And that will also be part of the demos I'll be showing today and some of the things we'll be talking about. And that is probably the most, when you take DevOps and try to make it concrete, GitOps is normally what people are talking to. And I'll show that again as demos today, and I'll try to give you some more ideas of what this actually means. So we'll focus on GitOps. The DevSecOps is where you take security and put that in the middle. And you should always do DevSecOps. You should always, I don't think it's called Git SecOps, so, but it's, you should always have security in mind when you do this. And I'll mention that a bit later as well. So how do you get started? So yeah, by learning the basics. There's a lot of things around the methodology around how you actually do DevOps. I found a lot of, I got a lot of value by reading some of the books. That is, I think they're mentioned quite a lot of places, but the Unicorn Project and the Phoenix Project, 2 books that's kind of semi-fiction and kind of something you can actually use in your day-to-day work. I have links for them in the end of this presentation, so so if you didn't catch the name, we'll mention them later. I even have a link for the first 6 episodes of the Unicorn Project, I think it is, on SoundForge, where you can actually go in and listen to it for free. So if you want to get started and listen to what it actually is. But again, start by learning what is DevOps, because there's so much value in it. Yeah, and it's more like a high-level thing. Then you need to choose your tools. So, and the tools you choose it doesn't matter. There's no right and wrong. So you can choose, you can do everything in Bash. You can also buy Azure DevOps and a ton of other tools. In my opinion, the most important thing is that you get something that you can actually maintain. And that's actually flexible enough for being able to maintain, not just for you as maybe as an IT admin, but for your entire team, and to get other people in that knows how to use this as well and can develop it. Because once you start going using GitOps, let's just call it that from now on, you need it's not something you do once and then it's done. It constantly evolves. The scanning tools you might use today for your security scanning might change in a month, and then you need to change it. And if you don't have a tool that's able to actually easily adapt to that, you'll have a hard time maintaining it. So, and there's a ton of tools out there. So find the tool that works for you. The other thing is start small. So you will fail. If you haven't done this before, you will make mistakes, and you need to learn from them. And take a small application, take something that at best something where you have control of both the code and everything else. But if you don't have that, take the smallest application you can find, something that's not business critical, and start to put this into a GitOps approach. Put the configuration into Git. Make sure you can deploy it again and again in an easy way. And start to design your application and maybe use some of the 12-factor app design principles that we talked about the last time to get an idea. You don't need to adopt everything necessarily, but start by getting your hands dirty. And when I started doing this, a good example is when you start using Git, a thing that pretty fast pops up is how do you manage secrets? Because you don't want to just put your secrets in GitHub. And yeah, I accidentally put my Amazon credentials 2 times into Git, and I had a not so pleasant call from VMware IT that said, "Hey, please fix." So I made mistakes as well, and you learn from it. And to just go with the mindset that you will make some mistakes, and there's things that you will change along the way. And then this is not something you can do alone. You need to get buy-in from all the stakeholders, every person in your flow, in your path to production. You need to get everybody on board. It's called DevOps for a reason. It's not. If you're doing it alone, you're probably either doing Dev or you're doing Ops, depending on what role you have. So you need to get everybody on board, and it's a cultural change. It's a different way of working. And it also requires you to hand off some of the things you do. So again, you can't sit there and do everything manual and have people asking you for, let's say, a virtual machine, a container, or a network port, or something like that. You need to give them the ability to do it themselves, to do self-service, to have an automated way of doing things, or else it won't work. So that's really important. And then, as I mentioned before, security is an extremely important thing in this. The whole idea behind doing DevOps and GitOps is to have some kind of automated release of your applications. And you don't want to release something that's not secure. So depending on what kind of application you're doing, you need to have some kind of, let's say you control the code, you probably want to do code scanning. If you don't control the code, then, and you just package it into a container, then you might want to scan that container, or make sure you don't have any important credentials in your pipeline or in your Git repository. Or let's say you don't control any of that. You might want to do port scanning afterwards of your application to make sure you don't suddenly open an extra port. And there's a tons of things. You know what kind of security layers you need to have on top of your application, but it should be an integrated part of your pipelines. Of course, you need to make sure that it's secure. Of course, you need to make sure that you don't release anything that has vulnerabilities that you didn't know of. And then measurement. That's pretty important as well. Of course, you need to measure what you do. If you don't measure it, how can you know that you're actually doing the right thing? So again, look at the way you deploy the application today. When you've actually done this, when you start using DevOps or GitOps, is it faster now? Can you actually deploy faster? Is it more secure? Is it more stable, or is it more flexible? There might be some of the measurement. It might not be all of them, but it might be just one or two. So pick a focus, pick where you want this application to succeed, where you want to improve it, and then go with that. And make sure you actually have some measurements. And say, yeah, before we did this, it took us a month of manual work to release this application. Now we can do it once a day, or 10 times a day, or whatever. It doesn't need to be 10 times a day, but just focus on that, so you have something you can actually show back and show this was actually worth the time, and actually worth taking into account for other projects as well, so it can grow. And then at some point, you'll probably hear about developer platforms, and my personal opinion is that that's not a first step. It might help you along the way. Some of the manual things you see today, a developer platform can probably help you a lot with that. And it can make some of the self-service for your developers, etc., a lot easier. But you need to have what we call the golden path. You need to be able to create a golden path. And the golden path is a signed off way on how you can get your applications into production. So what I mean with that is, let's take networking, for example. You can't have an automatic release of an application to production if you need to file a ticket for your networking or your security department. And it takes them 5 days to actually resolve that. You can't release 10 times a day then. So you need to have something where you say, if we follow these steps, this golden path, then the way we actually, then it's okay to release. As long as we were within these boundaries, then it's okay to release this into production. So But we'll talk a lot more about Golden Path and developer portals in webinar number 5 and number 6. So hang on. So with that, what new skills and tools are there needed to actually start doing this? The first one, it's without a doubt version control. And you might notice that I made Git pretty large, because in my opinion, there is not really any other alternative. But in reality, there is. There is a lot of different version control systems out there, but Git is just the de facto standard out there. So if you're using something else, then you need to make that work. But if you don't have any version control today, go for Git. That's the one. And spend some time learning Git. Git is in its basic form quite easy, but it can be so complex. And it's a really good skill to have. It's a necessary skill to have if you want to go down this path. CI/CD tools. So I put these together. CI, and that's continuous integration, and CD, that's continuous delivery. So the one is where you build things, and the other is where you deploy it. Some of these tools does both. Some only does CI, some does CD. And I just Googled it and said, hey, what kind of CI/CD tools do we have out there? We'll be looking at GitHub Actions today. And we'll also be using Argo CD. And we'll use GitHub Actions for the CI part, and we'll use Argo CD for the continuous delivery part. But there's a lot of others. And some of these tools, you might choose a tool out of what kind of source control system you have. So if you're using GitLab, it probably makes sense to use their CI/CD or their actions tool. I can't remember what it's called, their workers, runners, something like that, but where you can do all this automation. If you have Jenkins in-house today, maybe go for that. If you use Azure DevOps, and there's a lot of other tools out there. And it doesn't mean you have to choose one. You might actually choose quite a lot. As you can see today, the GitHub Actions and the Argo CD, they're not connected in any way, but they still maintain each of their part of this path to production that we'll go through later. It is quite easy to integrate different tools here. So it might be that you start by triggering something in GitLab, then you call out to Jenkins that does something, and then you call out to Flux that ends up deploying it. What do I know? So there's a lot of choice there, and it might change. So these tools change all the time. Then learn containers. So I think you kind of got that from the first webinar. You need to learn containers. It's a lot of these tools that I just mentioned are based on containers. So every time you start some kind of pipeline, it spins up a container with an environment where you can run everything from within. So it makes a lot of sense to be comfortable around containers. From my point of view, I learned a lot by actually learning the command line versions of containers. So there is things like Portainer and other that actually generates a UI where you can easily deploy new containers and do a lot of things. For me, it didn't help me by actually learning how a container worked. So, and doing more advanced stuff with them. I also recommend looking at Docker Compose, not exactly for the CI/CD part here, but Docker Compose is a way to describe one or more containers with dependencies in between, how they should start up, stop, share files, secrets, etc., to run your applications. See it kind of like Kubernetes, but just for a single host instead. So if you just need to run a single thing, then Docker Compose is a really nice way to start. Just for example, for the more nerdy of you out there, I run Docker Compose for everything I run at home on my NAS, because it doesn't make sense to run Kubernetes there. I don't need that functionality, but I need an easy way to be able to deploy applications that's portable, and Docker Compose helps me with that. But that's out of scope for here, so I'll just mention it. Kubernetes, that's more or less a given in my opinion anyway. Kubernetes provides you with a platform where you can run everything from. It's extremely scalable, it's extremely flexible, and it has a lot of plugins. So you can make it do more or less whatever you want. And you'll see that most of what we're doing today is based on Kubernetes. So, and again, there's tons of tools out there. kubectl is, of course, one of the basic ones. You can't really do anything with your Kubernetes cluster without that. You see me using it today. But one thing I find myself using all the time is something called K9s, which is a semi-graphical interface that helps you see all your containers and easily see logs, etc. So, but there's a ton of others. So find the one that works for you. So testing tools, that's really important as well. So depending on what kind of application you're deploying, you need to test it. If you want to run something automatically, you need to make sure that you have test in place. But depending on what kind of applications you're running, it's probably different types of test. So I mentioned a few here. I don't know all of them, but if you use a web-based UI application, you might use Celebrium to actually test that it actually works. If you want to do some kind of load testing, there's a PassJ meter. If you have APIs, Postman might help you. And there's a lot of other there. So look at your application and see what kind of test you need. A lot of the applications also have tests built in. So, and most of the development methodologies actually defines that you always test your application as part of building them. So you define the test first, and then you actually build the code. But that's a different thing. So, but you might not have that kind of access to your source code. So, but again, you need to test it. So, and then automation tools. So I said before that the CI/CD pipelines are normally, for a lot of cases, built by it's running inside a container. That seems to be the de facto standard. And most containers, if not all, are running in Linux. So Bash is a really good thing to know. How can you automate things using Bash? But for the more advanced things, Terraform, Ansible, SaltStack, Golang, Python, PowerShell, and all the others might help you to do more advanced things within your pipelines, to do your testing, to do your validation, etc. So pick your poison. Take the one that makes sense for you. If you're doing things with Windows, it might help you with PowerShell. If you're doing things with public clouds, etc., Terraform might be a good example. Yeah, and for me, Golang and Python is just easy tools to do some more advanced things that I would do in Bash. But again, Bash gets you a long way, a really long way. When you're done with that, we'll start by looking at the fun thing here. So you need to find your process. So, and for today's demo, I will run through my little simple process here. So the idea is that in the top one here, the purple one, we have my code. The first thing I do when I change my code is that I commit it to staging. So, and what is staging? So in Git, you have different branches. So the idea is that you can take your production code and then you can say, oh, I want to develop something new. So I make a new branch and I work on that branch until I actually commit it back into the production code again. So that is more or less how Git works, and it does that in a lot of different branches. So in this demo you will see today, I'll have two branches. I'll have a staging one and I'll have a production one. And I'm not able to push directly into production. Again, that's part of the 12-factor thing we talked about last time. I need to push things into staging. And when I push it into staging, it triggers a test. It's really, really simple dummy test. Then if that passes, it will go to actually build my container. It will push it to my container registry. And from there, it will deploy to my staging environment. And from there, I'll do a manual test. Again, this is a simple demo, so I don't have any automated test, but I should, of course, have that. Once I've said this is actually okay, this works, then I can do what we call a pull request, where I commit to production stage. Or to the production branch, sorry. And from there, it'll do some tests. I still think it won't in this case, but doesn't matter. And then it will deploy to production. So the whole idea here is that I both have my testing and I have my production, but all I need to focus on is my code. And again, this might be a bit complex. I'll try to make it slow, but let's see how it goes. A little disclaimer. I have two demos today. pretty extensive, so we'll be jumping around in a lot of different windows, and I'm not 100% certain that I get everything working. So, but let's see. The first thing I want to show you here, I'll just take this, I'll make it a bit bigger. This is GitHub. This is where I have my code. So you can see I have a couple of folders here, and I'll use it in a different view in a second. And I have my branch up here. This is my production branch, and this is my staging branch. So, and you'll see why that makes sense in a second. If I jump to my VS Code, let's see, this is the one, and I'll make it a lot bigger. I'll just do like this. Then this is the same as you just saw from if we go here, you can see the same folders here. The app, the Argo CD, the KLS is also over here. So the way this is built is I have a workflow folder up here, and every time I do a commit, it runs whatever is defined in this staging YAML file. And we'll go to that in a second. Then I have my application folder, and this application is exactly the same as the one we looked at the last time. So this is my small web server, the Tanzu webinars demo, where I can see a small web server. Also, I have a Docker file that defines how my how my application looks, stuff like that. Then I have an Argo CD folder, and this defines the tool I use to actually deploy this. We'll get back to that in a second. So, and then I have my Kubernetes configuration, and my Kubernetes configuration defines a deployment. So we also went through this the last time, only a single replica and some specifications and which port I'm going to use. And also here, which service do I want to expose? So I'm exposing port 80 to the outside, but I'm using port 5000 in the end, and I'm using a load balancer. Note up here, there is no namespaces. So that's an important thing. And if I do, just here, get ns, then I can see my Kubernetes cluster that I'm running everything on here. And in this Kubernetes cluster, I have three things that's important. I have my Argo CD. This is the continuous delivery thing that I'm going to be using. But also I have a production folder, and I have a staging folder. They call namespaces, but let's call them folders just for the fun of this. This is where my applications will be running. And in here, I've defined for Argo CD, I've defined how I want my applications to be deployed. So I pointed to my GitHub repository. I told it this is for the production one. I told them to use the production branch in the path Kubernetes KLS, which is this one. And then I told it to deploy to the namespace production, and it can create it and stuff like that. That's not important. And the same for staging here, that I'm using the staging namespace and the same folder. So a couple of things here. If we go to here and I say applications, and this is Argo CD. And this defines my applications here. So if I click here, I can see all the different components that's running right now. This is my application that's running. And if we go and say get/a, we get all the services that's running right now. And I say I want staging, then I get this IP address. And if I go to my web server and I point this in, it will say Tanzu webinars demo is working in version 4. So this is exactly what you saw here. So let's now change this to version 5. I'll save it. I will give it a label that's called version 5. This is my changelog, and I'll commit it. You can see down here it says staging. I'll commit it here, and I'll say commit, and then I'll do a sync. What happens? Come on. This is how we know it's live demo. I have to have a little error, but it works now. What happens now is that I've created this document, and this, just bear with me for a second. And I told it, when something happens in the staging branch, then start by doing a test. It runs on a container here, an Ubuntu one. It checks out the code, and then it runs a simple test. Then it goes to the build phase, and again, it checks it out. And then it sets up all the things it needs to create the Docker container. Then it builds the Docker container with this name. Again, it's the same as we looked at the last time. I get the label latest. Then I push it to my container registry. So I build it, and then I push it to my container registry. And then the tag it gets applied to my deployment file. And then I commit that. So if I look at my deployment file, you can see it has this share. And this is not something you would normally know, but this is the specific version of the application that I'm building. So if I go back now and I say actions here, you'll see that it's running this version 5 as we just talked about before. And if I click on this, you will see that it already ran the test. Click, and we say app test. You can say it says it's working. Then I can go to the build, and I can see that it ran through everything here, which means that it's just built the application and it pushed it to my registry, just like we looked at the last time. Now just everything is automated. If I go to my staging app here, then it says everything is okay. But if I say refresh, then it says, oh, something is out of sync. It starts to pull down the new container here. And in a few seconds, it will replace my existing container with the new one. So what Argo CD does, the whole purpose of Argo CD is to look at my source repository and my Kubernetes cluster and make sure they're in sync. The source of truth is always the Git repo. That's always what the source of truth is. If something changes there, then Argo will make sure to change it so that it reflects what is said in how it looks in Git. And if I go to my application and I say refresh, then it says version 5. So I've just updated my application automatically. I did a manual refresh, but that's because it does this refresh every 3 or 5 minutes. So I just jumped a bit ahead. But this will happen within 5 minutes. You can also do a webhook or something like that that automatically triggers it. But that's not for this demo. So just so you're aware. So I just updated this. But let's, for fun, go back and say, I saw all the services that was running here. And I also have the one for production, which is 104 here, the other IP address. Jump back here and open a new tab. And you can see this one is still running version 4. So we have version 5 in staging, and we have version 4 in production. So how do I get to, actually, after tested it, everything works, how do I actually get this into production? I do that by going to the correct folder. I go to my code here, and it says staging had a recent push 4 minutes ago. Do I want to compare and do a pull request? So pull request is where I create a kind of a ticket that says, this is how staging looked like. Please merge this into production. And I can say compare. We can call this version 5 and upgrade it to version v5. And I can say create pull request. It is real simple. And now it checks for a lot of things here. It does security. It does a lot of things. It checks if some of the code in staging conflicts with what's in production. So, and in this case, there shouldn't be anything. So, and other people can also go in and actually check it. In this case, I haven't set up any policies, but I could have a policy that said, I'm not allowed to do any push into production unless 2 other people has actually verified that this worked. So there's a lot of things you can do. And let's see if I can refresh it. See if it's done. It is. All checks have passed. Do I want to merge this? And I want to. So I click merge, give it a name, and say confirm merge. Again, this is real simple. I can delete the branch, but I don't want to because I'm actually using that branch. If we go back now and we take Argo CD and we go back to production, click on this and say refresh, then the same thing happens. It's out of sync. So it will start by syncing it down to the production folder. And if I go to this one now and I say refresh, then now we're running version 5. So this is basically how GitOps works. So all I need to focus on as a developer is my code. All the other things has already been set up. And if I look at, again, Argo CD, just an example, everything is green. I can see my applications are working, stuff like that. if I delete something from my application, let's say I accidentally delete a service or something else, then Argo CD will actually fix it. So it's also self-healing because I've told it could be that. Let's look at staging here, just for fun. Let's go to here, and let's say the staging service. If I say, okay, delete service, and I'll delete the service that's available. And if I go back here, then you should see in 2 seconds, I just deleted the service, so the application wouldn't work now. And if I refresh, and this is the probably, error from service, demo app staging. Why doesn't that work? We'll try one more time. Staging, demo app, staging service. We'll try again. I need the right, sorry. Of course, I need to be in the right namespace. Staging. So I'll delete it now. Boom. You can see it got deleted and now got recreated. It went so fast that we almost didn't notice. But this works again. So this Argo CD makes sure that everything is running at all times. So it's pretty clever. And again, Flux does the same. There's other tools that does the same. So this is just an example. Argo CD just have a nice graphical interface. So it's easy to show you guys. With that, I hope that made just a little bit of sense. I will go back. I'll talk a little bit about how do you actually create the platform I just had here. So the Kubernetes platform, how do you actually create that so you can use it? And you might also be thinking, yeah, that's fine. He just showed a lot of things. How easy is it to actually set that up? And it is actually quite easy. So let me show you in 2 seconds. So I work from VMware, and VMware has a Kubernetes service. So if you're running vSphere today, it's quite easy to get Kubernetes on top of that. So it's as easy as defining a couple of networks, a load balancer, and a couple of stuff that makes it really easy for others to consume it. And this Kubernetes platform it's not managed, but it is maintained so that if something breaks, we kill the node and we deploy a new one. So we maintain the health of it at all times. Just like we talked about the last time with cats versus cattle, we treat this as cattle. We treat it as something that is disposable. We can scale it easily and stuff like that. And we're able to run this in different clouds. We can run Windows containers. If anybody out there can tell me what the reason for running a Windows container is, I would be so happy because I haven't seen the use case yet, but that might come. But for now, 99.9% is probably Linux containers. We can add GPUs to it as well. So if you suddenly have like ML AI use cases, then it's quite easy to do that. We can integrate it with something called Tanzu Mission Control, which is a management plane. We'll look at that the next time. So you'll see how you do everything I'm doing today a lot easier. And something called Tanzu Application Platform, which is the developer platform that I talked about before. And again, that's for a later time as well. And we also have a lot of packages built in. So when you deploy this Kubernetes platform, it's quite easy to get other services on top of it. So you don't need to reinvent the wheel. So I use Harbor, for example, the one you can see up here for my container registry. So it's easy to get something like that. We deployed using something called Cluster API, which is a declarative way to deploy Kubernetes clusters, easy way. And there's a lot of other things. If you want to monitor things, we have Grafana, Prometheus that integrates with that, logging used to Fluentbit, a lot of things. You don't need to know all of them, but just be aware that some of the more, some of the better open source projects are included and easy to integrate. So you can easily get a platform that's usable for your use case. And we can also create Kubernetes clusters with, let's say, just one management plane, because if it's just test, then there's no reason to have 3 every time. So we can also create big scalable clusters, etc. So, but it is an easy way to consume it. And we also make sure that we have official images you can just deploy and use in an easy way. So having Kubernetes as a service on top of your vSphere environment is an easy thing, or at least it should be. So with that, let me show you how that actually works. So the first thing I'm going to do is I'm going to shut down this window, and I'm going to jump to my other VS Code window. See if I can get this up here. This is where I said I had quite a lot of things running. Yes, this one. And then I have a vSphere environment here. Let's hope I'm still logged in. I am. And I think that's it for now. Just rearrange them. So this is the folder that we used earlier. And what you should see now, I can hide this, hide floating meeting controls. Yes. So, okay, get nodes. And down here, you should see that I'm right now working on a pre-cluster. So if I want to create a new cluster, and this was the one I'm working on now, bigger. One more, yeah. The way vSphere or the Tanzu Kubernetes grid works in vSphere is that I, as a vSphere admin, can create something called a vSphere namespace. And they're quite simple. You go in and you say workload management, and then you say, I want to create a new namespace. You select where you want to deploy it. We can just call this webinars, and I'll create it. And in here, I can give different permissions, and I'm using the same permissions. So if I have vCenter Active Directory integrated, then I would use the same permissions that I got from there. So the same users. So I don't have that. So I'll just use my vSphere local administrator. I give it access to some storage here. Come on. I think I made it a bit too big, so I can't click the button here. And here I can use the exact same constructs as we know from vSphere. I can use that to my Kubernetes clusters. So I just give a storage policy here. I can define resource limits. So if I don't even want my Kubernetes admins to just consume whatever they want, then I can add a limit on CPU, memory, and storage. And I can also select something called VM classes. And VM classes is the different sizes that I would allow my users to deploy Kubernetes nodes in. So if I don't want them to deploy 32 CPUs and 128 gigs of memory, then I won't give them access to this. I'll just say small, medium, large in this case. And that's it. Once I've done these things, added storage, permissions, and the templates, then I can give my users access to deploy Kubernetes clusters within this construct. So I've defined a couple of resources where my users can have fun. And what my users would do, they would go over here and they will say, define a Kubernetes cluster. And in this case, they run a YAML file, just like you've seen a couple of times here. I give it a name. I select how many control planes I want. I select the VM class, this is the templates we talked about before. I select the storage class, which kind of storage, and I give them a bit of extra storage. Select the version of Kubernetes, 3 nodes, and again, the same again, a bit of extra storage, the version of Kubernetes, and I select my default. And that's it. They can define this and say, I want to deploy this. And if we go here, I'll make this a bit bigger here. I'll just say make setup because I need to log in. And then I'm logging in to the management interface of this. This is the supervisor cluster that I'm logging into. And then I'll say kubectl apply /f to point to a file. I'll point to the KLS file, and I'll select the namespace. Webinars. I'll say enter. And just like deploying any other Kubernetes application, service, etc., I've just told my vSphere environment that I want a new Kubernetes cluster. And this is not the correct one, this one. And within a couple of seconds, hopefully, you should see a Kubernetes cluster being deployed. There it is. So we will now start to deploy some of the nodes. It creates a resource pools, it creates folders, it creates the VMs. You can see it's pulling the VMs from the contents catalog, that's where it gets its templates from. And you can see everything is starting to be deployed here. We won't use this for the rest of this demo because it takes 10 minutes before it's actually up and running. But that was all I need to do. And I can kill it again and create a new one if I want to. So being a vSphere or a Kubernetes admin, I can easily consume this on the vSphere environment within the defined constructs that were given to me. quite easy. But I'll do something else here. I will make this a bit bigger. I hope you trust me that this will work. And then I'll say I did make cluster. I need to find the right one. I have a template file here that allows me to log into the cluster here. Log in cluster pre. So I'll log into the one I need to log into to show this demo. Takes 2 seconds. So get ns. So here you can see the namespaces, and you can see this is pretty clean. It was deployed 19 hours ago. It doesn't have anything. It doesn't have Argo CD. It doesn't have any applications, production, or anything like that. But let's do that. So the first thing I need to do is I need to allow my users to actually deploy or create containers. So there's a bit of strict permissions defined when you deploy this Kubernetes cluster. And that's it. I just created some cross-row bindings, as it's called. Then I want to create a namespace called Argo CD, because I want to actually do what you just saw before. Then I want to install Argo CD, and I pointed to a web URL that points to the YAML file that I want to install. If you do like this, then it starts to actually deploy this in this namespace that I just created before. And it takes a couple of seconds before it's actually done. You see, create roles, create service accounts, create all the things that this applications needs to do. So it takes 2 seconds. Come on. It always takes longer when you're doing live demos. So note that it's pulling everything right now from the internet. And that's it. So I've created the Argo CD. I need to be able to access it. And to do that, I need to tell it to use a load balancer instead. And then I'll want to get the IP address of that load balancer. And the IP address is here. So this is the new Argo CD I just deployed. But another thing I need to do is I also need to get a password. And this password is generated as a secret. And this is the one that I can use for this one. So, but let's start by taking this one and going to open this site. I want to accept the risk. And I should see a login for Argo CD. The default username is admin, and the password is this one. Sign in. Oh, and you can see I got exactly the same as I showed you before in Argo CD. This one is just clean. So how do we get our production application deployed? Well, that's pretty easy, because I have a YAML file over here, as I showed you earlier. This is the Argo CD configuration. Everything here, just like everything else, is defined in a YAML file. Where it takes where the GitHub repository is, what kind of branch, and all the things we went through before. So if I want to deploy this, all I need to do, go down here and say kubectl apply and point it to my production file. And if I do that, you will see, come on, boom, it got created. It says it's out of sync, and it will start by pulling down all the things it needs to make sure that the application is actually running. If I now say get ns, you should see that I now got Argo CD, but I also got my production application. And if I say get svc/all, get all the services that is available right now, I can see the demo app down here. It says pending. It needs 2 seconds to actually get an IP address. Come on. Yeah, this is where, again, you can see this is a live demo. Come on, it takes way too long. Okay. Not much of a demo if this one doesn't work. So this one is talking to the load balancer and requesting an IP address. So I don't know why. I might have tried it too many times for this to work. Okay, I'll do a last test. Okay, it doesn't get an IP address for some strange reason. So what I'll do instead is I'll take the K9S, as I talked about earlier. We can show you this instead. You can see this is all the applications that's running right now. And down here, I should have one called production. And if I click on it, and then I can say I want to use a port forward, and I want to expose my local port to this. Good. So if I take this and I say localhost 5000, then I should see my Tanzu demo application is working, version 5. So again, I should have had a public IP here that was working, but we need to do it this way instead. So, and connect directly to it. But the interesting part here is I just spun up a new cluster. Again, I used one that was pre-deployed for yesterday. I quite easily deployed Argo CD, and all I needed to do was point to a configuration, and then I suddenly had my application running here. This is the exact same application as I have running on the other cluster, but they're independent. So there is, if one goes down, the other one will still work. I, of course, need some kind of global load balancer for this to work, for this to be usable for, but it's a different methodology that you might use when you're running, let's say, a stretch cluster on vSphere. This is two independent Kubernetes clusters that can run the same application. If there's data involved, then of course I need some kind of sync between them. But just start to think about this. It's a different way to design your applications. So just like in the old days, when you defined your infrastructure based on hardware, you did things a specific way. Then VMware came and did stretch clusters, etc. And then you started to define your things in a different way again. Now we have the cloud native way of doing things. And suddenly you might not need a stretch cluster to be able to have something highly available. You might need to define your availability in your application layer instead. And that requires you to actually know the application. It requires you to have some kind of global load balancer or service mesh or something else, which is out of scope for this presentation today. But it's a different thing. So I hope that was kind of an eye-opener. So, so that was it for today. I hope you found it interesting. I hope it was okay and it wasn't too complex. The next time we'll be talking about multi-cloud deployment. So we'll talk about the Tanzu mission control. I will have my colleague Victor van der Berg with me, who's an expert in this and will show a lot of things here. So so you're not stuck with only listening to me the next time. And then some of the things here is I mentioned a couple of links. So we have the Unicorn project. I have links for that. The audiobook that you can see on SoundCloud, the first 6 chapters, the Phoenix project, and then just some of the other links. And also, if you want to register for the next event, see the recording. I hope to have it out no later than tomorrow, but again, I'll do it as fast as I can. And I'll put everything on the webinars.tanzu.dk. So I hope you found this enjoyable. I'll just see if there is any Q&A. Yes, so the first question here is, how would you recommend building staging in an internet restricted environment? So everything you saw, you need to have every component locally. That's important. So I pulled all the images from the external hub, etc. But you could have, let's say I use the Ubuntu image. I could have that on my local Harbor instance, on my local registry, and pull that. The Git, if you use GitLab, for example, that is on-prem. You could use that. And then you wouldn't need to communicate with anything on the internet here. So you can do everything restricted. So, and it's actually quite easy. Also, if you take something like Harbor, other products can do the same as well. You can actually sync the registries. So let's imagine that we have 2 different data centers where you want the same things to be available both places. You can set up your registry so that it syncs between. So if you push something to one registry, it syncs it between the other ones. And you can do the same with more or less everything that you have. So I hope that that answered your question. I don't know if I can say, no, I can't. So Any other questions? If not, then I'll stay on for 5 or 10 minutes. So you're more than welcome to just ask. Reach out to me. You can scan the QR code here if you want to see some of my contact details. Connect with me on LinkedIn, Twitter, etc. If you have any questions, I'm more than happy. And if not, then I hope to see a lot of you next time as well. So yeah, Christian, you have a question. I don't know if you can unmute yourself. I haven't really. Yeah. No. If not, then write in the Q&A and I'm happy to answer. And I'll just stop the recording for now.